Every star begins as a collection of gas and dust. Eventually, gravity pulls all of this into each other, and the mass becomes greater and gravity gets stronger enough to collect into what's called a protostar. A protostar is a cloud of gas undergoing gravitational contraction as it is developing into a star. The celestial object made up of the contracting of interstellar medium is mostly hydrogen gas. Soon the star begins fusing hydrogen into helium and it becomes a main sequence star. This is where our sun is right now. The way a main sequence star and all other stars exist is because it is a balance in between the gravity of the star and the radiation pressure from nuclear fusion. The star is fusing hydrogen into helium in its core, and that creates a pressure outwards and releasing energy, and that is balanced in between the gravity and the mass of the star pulling everything in. For example, in the case of a red supergiant, the core fuses hydrogen into helium, helium into carbon, carbon into oxygen, oxygen into neon, neon into magnesium, magnesium into silicon, and then finally silicon into iron. To rewind everything, we have a collection of gas and dust. We have gravity clumps things together, and it sticks and sticks and sticks until it turns into mass. And this, as of right now, there's no fusion in it, so this is what we call a protostar. Eventually, hydrogen in the collection of gas and dust begins fusing into helium. This is when it changes into a main sequence star. This is when the fusion process makes a radiation pressure, which is pushing outward, and the gravity is pushing inward. So it's a balance in between those two things. And then it's fusing helium in the middle, and then eventually it will begin fusing carbon, and then carbon into oxygen, oxygen into neon, neon into magnesium, magnesium into silicon, and finally it will fuse silicon into iron, and the iron will expand. And then it will try and fuse iron into iron, but it is too heavy and unstable, and it cannot do that. So the radiation pressure that was pushing outward is now turned off, and the gravity is very strong. Meanwhile, in the other layers, it's still fusing, so that has an energy process which is pushing out. There's no longer the gravity of the iron core pushing everything in, so all the layers eject and explode and fly off into space in what we refer to as a supernova, or if it is significantly stronger, eventually a hypernova, which is a pretty sick name for an explosion. But anyway, all we have left is the iron core. The mass of the iron core is so heavy and the gravity is so strong, it takes the molecules of iron. We actually have to examine this on the quantum level. So we have an atom is the balance in between the electron, which is floating around it, and with a negative charge, and then the protons and neutrons, which are in the middle, and the protons have a positive charge and the neutrons have a neutral charge. And atoms are mostly space. So if you had an electron orbit of what is the size of a football stadium, the nucleus would be the size of a marble. So you have the gravity being so strong, it takes the electrons and it forces them to bind with the protons and create neutrons. So you no longer have that empty spaces there, and the gravity it pulls everything together. So you have all those marbles. That's how dense it is. It is as dense as it physically could possibly be. And in addition to that, it is so dense that 1 cubic centimeter of this neutron star material would be the same weight as 1 billion tons, also known as Mount Everest. If the star has more than 8 solar masses, then it does the same process of layering like an onion and fusing heavier and heavier elements and then ejecting everything else besides the iron core. But since the iron core is more dense, the gravity is so strong that it forms an object which is known as a black hole, which is so dense that not even light can escape its gravity. The star does not have enough mass to become a neutron star, along with which is our star and 97% of the Milky Way stars. It stops its expanding red giant phase at oxygen, and it cannot fuse oxygen and carbon into neon, and it still ejects all of its layers in what's called a supernova, and the inside core of carbon and oxygen remains stagnant.